So this is part two of our mineral notes, and what I want you to, this will be short because we're just talking about some of the characteristics of other characteristics of minerals, and we group minerals by their chemical properties. Sometimes the elements silicon and oxygen combine to form what's called a tetrahedron or tetrahedral, where you have one silicon atom and four oxygen atoms that make this sort of triangular shape. And the silicate minerals, the silicates, the ones that are composed of silicon and oxygen, are the most abundant minerals that we have. They make up the most abundant elements in the Earth's crust, and so we have a lot of these silicate elements. And part of the reason is because they can combine in so many different ways. They can be they can be just single tetrahedrons together that would make olivine. They can be in chains where they're bonded. Instead of having four molecules for each of oxygen for each silicon, they share one of those oxygens and they make a chain. Sometimes they make double chains where these amphiboles, and they make sometimes they make sheets, and that's why these micas split along flat planes that you'll see in the lab. And sometimes they're sharing the silicon molecules are sharing more than one of the oxygens. They're sharing a lot of them with their neighbors in these different covalent bonds, and so you get quartz and feldspars, and that's what makes quartz so hard, such a hard mineral, because of the way that the atoms are bonded together. And that's one of the key points that I want to make, is that the physical properties always depend on the internal arrangement of the atoms. The arrangement of the way that these atoms are arranged or combined determines how they're going to react. So these sheet minerals, because the atoms are arranged in a certain way, they break into nice flat planes. But because these atoms are bonded differently, they are stronger, the bonds between them are stronger, they don't break on regular patterns. So when you hit a piece of quartz, it fractures. It doesn't break along cleavage planes like the micas do. And it's because of the internal arrangement of the atoms. We saw this with our example of diamonds and graphite. Diamond is the hardest known natural mineral. It scratches and cuts any other minerals, whereas graphite is one of the softest. It's a 1 on the scale. They're both made out of the exact same thing. Their chemical composition is exactly the same. The way that those atoms are combined and bonded together is the big difference between diamonds and graphite. And if you remember that from when I showed you those videos at the beginning of the unit, that's where that comes in. Most of the thousands of known minerals, only a few are found almost everywhere, and if you can identify those dozen or so common minerals, you'll be able to identify most minerals and rocks that we're likely to find. And that's why we're concerned about minerals. We want to be able to identify rocks. And rocks tell us stories. Minerals tell us stories. They tell us the stories of the history of an area. And that's why we want to understand what's going on with rocks and minerals. Most rocks, almost all of them, are composed of one or more minerals, and their minerals are the building blocks of most rocks. Some of the exceptions: coal and limestone. Now think about that for a second. What is it? We talked about coal before with Pangea and finding this coal in Antarctica was proof that plants were once there. Why is it that coal would not be a mineral? If you think about that for a second, why would that be? Coal and limestone both come from living things. So they're organic materials. So they're not minerals, but they do make up rocks. So those are sort of the exceptions to the rule there, to this rule of all rocks are made out of minerals. We classify rocks. This is just getting back to some basics of what we're going to be doing in the future based on how they're formed. Igneous rocks, if you remember, formed from melting and solidifying of molten rock. Sedimentary rocks, deposition, burial, compaction, and cementing of sediments. So sediments are pieces of rock that are broken up. They get buried, deposited, buried, compacted, and cemented together to create a sedimentary rock. And metamorphic rocks are just formed from any other rock when they get under extreme heat and pressure. That's where those metamorphic rocks come from. So we'll spend a lot more time talking about igneous, sedimentary, metamorphic rocks, but just know that they all form from minerals. They're all composed of minerals. And that's all.